Welcome, everyone. Ready to dive into the world of semiconductors.
Absolutely. Should be fascinating.
We're cracking open Chris Miller's book, Chip War, and I have a feeling this is going to be one wild ride.
Yeah, what really struck me about the book is, it reveals how these tiny chips, something most of us never really think about, they're actually at the heart of global power struggles,
Mm.
economic dominance, even military supremacy. It's all tied up in these tiny things.
Okay, so let's break this down, right? I mean, I know chips are basically in everything I use, like my phone, my laptop, but I never really thought much about, like, the history behind them or the geopolitical forces that are all, swirling around them. Where do we even begin with something this complex?
Well, I think the story of the chip, it's really a story of innovation,
Mm.
driven by both scientific breakthroughs, but also this really intense global competition, right? You can't separate the two. But to really understand where we are today with all this, we kind of have to go back to the beginning. Remember those giant room-sized computers that use vacuum tubes?
Vaguely, yeah. I mean, mostly from old movies, I guess. Weren't those things notoriously unreliable?
Oh, they were. They were bulky, generated tons of heat,
Mm.
and yeah, they just loved to burn out. Plus, and Miller points this out, they actually attracted moths.
Moths.
Yeah, moths, which would then cause short circuits.
Oh, wow.
So imagine having to debug a computer by literally, like, removing a moth from its circuitry.
That's a debugging story I haven't heard before. And a far cry from the sleek devices we have now. So how did we get from, like, moth-infested computers to the chips that are, in everything around us?
Well, the transistor,
Right.
invented in 1947, that was a huge step forward. This tiny device, it could amplify and switch electronic signals, replacing those, much larger, less efficient vacuum tubes.
Hmm.
But the real game changer, the one that really set everything in motion, came a bit later, in 1958, with the invention of the integrated circuit, or, as we know it better, the chip, by Jack Kilby at Texas Instruments and Robert Noyce at Fairchild Semiconductor.
So that's the birth of the chip as we know it. Was that the moment, like, Silicon Valley as we know it was born?
It pretty much was.
Yeah.
Noyce would later go on to co-found Intel, and a lot of the major players, the big names, in those like really early days of the chip industry, they came out of Fairchild Semiconductor. There's a great story in the book about the Traitorous Eight, this group of engineers that left Shockley Semiconductor to start Fairchild.
The traitorous eight.
Yeah. And these eight, including, and this is pretty amazing, Gordon Moore, yes, that Moore from Moore's Law, they essentially laid the foundation for the tech hub we know today as Silicon Valley.
So, okay, we've got the transistor, the integrated circuit, Silicon Valley is starting to, take shape. But early on, this whole industry, it was heavily influenced by the Cold War, right?
Oh, absolutely. Military funding and, the space race, they played a massive role in driving those early innovations in chip technology.
Mm.
I mean, the U.S. military, they needed miniaturized electronics for, well, everything, really. Things like the Minuteman VI, the missile,
Right.
the Apollo program. All this spurred on, like, incredible advancements in chip tech. I mean, you could argue that national security concerns, they basically fueled those tech advancements that, well, that later defined the consumer electronics industry as we know it.
So these early chips, they weren't just, powering calculators. They were helping put people in space and, well, also guiding weapons. That's a bit of a complicated legacy.
It is, definitely.
Yeah.
But at the same time, alongside all these military applications, there was also, this push to make chips cheaper and more efficient, right, for consumer products. And this, I think, is really what led to a really major shift in the industry, globalization.
Okay, globalization. So how did that play out in those early days?
Well, you had companies like Fairchild Semiconductor, Texas Instruments. They started offshoring their assembly operations to places like Hong Kong, Taiwan, anywhere where labor costs were significantly lower.
All right, the quest for cheaper labor, I guess that was the first step toward the globalization of the chip industry. But Miller also talks about, these clashes of cultures that happened in those early days. What was that story about Mark Shepard in Taiwan?
Yeah. This seemingly minor anecdote about Mark Shepard. He was the chairman of Texas Instruments at the time. On his first trip to Taiwan in the late 1960s, it actually, I think, reveals a deeper tension, right? On this trip, he clashed with the Taiwanese economy minister, KT Lai, over intellectual property. Shepard, he saw, protecting IP as absolutely essential, whereas Lai, he kind of viewed it as this tool of Western imperialism, this difference in perspective. It really foreshadowed all those challenges that would arise as the chip industry became more and more globalized.
Wow, that's fascinating. It's like a microcosm of, that whole US-China rivalry over intellectual property we're seeing play out today. Okay, so the chip industry is going global, the Cold War is raging, and then Japan enters the scene, right?
Exactly. Right around the 1980s, Japan, they emerged as a real semiconductor powerhouse. They challenged American dominance in the industry head on. Companies like Sony with their, innovative consumer electronics, things like the Walkman and other Japanese manufacturers, they captured like a massive share of the DRAM market.
Dear.
Dynamic random access memory. For those of us who aren't, chip experts, it's the type of memory that's, well, it's commonly used in computers and other devices.
Yeah.
So Japan, they're making major inroads, and Silicon Valley, understandably, started to panic a bit.
I can see why. Wasn't there an American company, GCA, that really struggled around that time?
Yeah, GCA, they were America's, leading lithography equipment maker. Lithography is the process of actually printing circuits on silicon wafers, and they were like totally dominant in the early days. But then they, I guess you could say, got a bit complacent, failed to really innovate as the market shifted. Japanese companies like Nikon, with their, real focus on manufacturing excellence and this idea of, continuous improvement, they took over the market. GCA's downfall is it's a classic case of the innovator's dilemma. They were like so successful that they didn't see the need to change until it was too late.
So how did Silicon Valley fight back against this, Japanese challenge?
Well, the U.S. response, it was multifaceted, right? They adopted some of those Japanese manufacturing techniques, that focus on quality and efficiency. But they also shifted their focus to new markets, things like microprocessors, which were becoming increasingly important for personal computers. And maybe ironically, they continued offshoring production to Taiwan and South Korea. Basically, they learned from their competitor, while leveraging that globalized supply chain they had already built.
So Silicon Valley adapts, the Cold War ends. You'd think things would calm down a bit at that point, but if anything, it seems like chips became even more important, especially when it comes to modern warfare.
That's right. Back in the 1970s, William Perry, he was a Pentagon official at the time, he had this vision, right, of precision strike weapons, guided by chips and relying on, information rather than just sheer firepower. This whole shift from volume of firepower to information-based warfare, it was dramatically demonstrated in the 1991 Gulf War.
Yeah, I remember those images, those smart bombs and guided missiles, all powered by those tiny chips. It was a turning point for sure, showcasing that decisive advantage that chip technology could give you on the battlefield, almost like chips became the new weapons of mass destruction in a way.
Yeah, in a sense, you're right. They became crucial, not just for consumer electronics or raw computing power, but for national security, global power dynamics, the whole thing. And that brings us to the modern era and, well, the rise of a new challenger, China.
Okay, so let's dive into that. China is this major player in the tech world today, but how did they get there? And what are their ambitions when it comes to chips?
China's rise in the chip industry, it's a fascinating story, but it's also a source of considerable tension with the U.S. China, under President Xi Jinping, has made it a national priority to achieve breakthroughs in core technology, particularly semiconductors. They see that they're, heavily reliant on foreign chips, especially for advanced technologies, and they want to change that.
So China wants to be, what, self-sufficient when it comes to chips. How are they trying to achieve that? And what's been the U.S. response to all of this? It feels like the start of a whole new chapter in this chip war.
Oh, it definitely is, and it's a chapter that's still, being written. But to understand what's happening today, I think we need to look at how China's been trying to catch up in the chip industry. And, well, that's where things get even more interesting. So China's approach to all this has been kind of two-pronged, right? On one hand, they've been investing crazy amounts of money in their own domestic chip-making capacity, building these huge new factories, they call them fabs, and pouring resources into research and development. But at the same time, on the other hand, they've been, pretty aggressively trying to acquire foreign technology through investments, partnerships, and some would argue, some less savory tactics, things like intellectual property theft and forced technology transfer.
So it's a combination of building it themselves and allegedly, taking it from others. Which, yeah, that's definitely going to raise some eyebrows, especially in the U.S. What are some specific examples of these tactics?
Well, one of the most interesting stories in the book, I think, involves IBM. After the Snowden leaks in 2013, those leaks that revealed just how much the U.S. government was surveilling everyone, IBM sales in China, they just, like, tanked.
Yeah, that makes sense.
Their Chinese customers, they suddenly became very wary of using American technology, right? Fearing that it might be, I don't know, compromised somehow or subject to, like, U.S. government interference.
So what did IBM do to, kind of regain its footing in the Chinese market after all that?
Well, Ginny Grumedy, who was the CEO at the time, she saw an opportunity. She offered to, share some of their semiconductor technology with Chinese partners in exchange for, well, basically market access. It was a pretty pragmatic move, though definitely controversial. IBM, they were basically trying to balance, their business interests with this increasingly complex geopolitical landscape.
Yeah, like a classic if you can't beat 'em, join 'em kind of thing. But it also highlights that, that tension between national security and the increasingly globalized nature of the tech industry. How did the U.S. government react to IBM, making these kinds of deals?
The U.S. government, they've grown increasingly concerned about China's chip ambitions.
Right.
Right. And the methods they're using to catch up. There have been accusations of Chinese companies engaging in, well, all sorts of things. Intellectual property theft, forced technology transfer, you name it. Even like industrial espionage, trying to acquire sensitive chip technology. This has led to a pretty significant shift in U.S. policy, with a much greater emphasis now on restricting tech transfer to China and investing more in, domestic manufacturing here in the U.S.
So this chip war, it's like really heating up now. It's not just about, competition anymore. It's about national security, economic dominance, the whole thing. Which Chinese companies are at the forefront of all this?
But Huawei is a prime example. They went from importing, basic telephone switches to becoming this global leader in 5G technology.
Right.
But their success, it's come under intense scrutiny, lots of accusations of close ties to the Chinese government and potential security risks.
Yeah, I've heard about that. Didn't the U.S. actually label Huawei a national security threat and ban them from, doing business with American companies?
They did. The concern is that Huawei's equipment, which is used in, telecom networks all over the world, could be used for, like, espionage or even sabotage, giving the Chinese government an advantage. Huawei, of course, they deny these allegations.
Right.
They say they're just a private company, no ties to the Chinese government. But the U.S. government, well, they remain skeptical, to say the least.
It's like this high-stakes game of chess with these companies caught in the middle.
Yeah.
What's so fascinating to me is that while we're talking about, all this competition, can the U.S. and China really decouple their tech sectors when it comes to something as complex as chips? I mean, is that even possible?
That is the billion-dollar question. The reality is that global chip supply chain, it's mind-bogglingly complex, incredibly interconnected. To untangle all that, it would be, insanely difficult and costly for both sides. But the U.S. is clearly trying to, reduce their reliance on China for those critical technologies.
Yeah.
While China, at the same time, they're pushing for greater self-sufficiency. This whole push and pull, it's going to continue to shape the industry for years to come.
So it sounds like we're headed towards, I don't know, a more fragmented tech world, which, I mean, that raises all sorts of questions, right? About innovation, costs, access to technology, the whole thing. But amidst all this, geopolitical maneuvering, we haven't really talked about the future of the technology itself. What about Moore's Law? Is it still, is it still holding true?
That's the question that's been, debated for years. Moore's Law, which basically states that the number of transistors on a chip doubles roughly every 2 years. It's held remarkably true, for decades. But as these transistors get smaller and smaller, those physical limitations of silicon, they're becoming, increasingly apparent. It's getting harder and harder to, cram more transistors onto a chip without hitting all sorts of engineering challenges, not to mention the skyrocketing cost of actually building those cutting-edge factories.
So are we saying that Moore's Law is, dead? Does that mean innovation in the chip industry is slowing down?
Not necessarily. It's more accurate to say that Moore's Law is, it's slowing down, not dying. The industry is exploring, all sorts of new ways to increase computing power, ways that don't rely on just, making transistors ever smaller. One promising avenue is 3D chip design, which basically involves, stacking chips on top of each other to create more powerful and more efficient processors. Think of it like building vertically instead of horizontally. Allows for more computing power in the same amount of space.
Okay, so instead of just trying to, cram more and more transistors onto a flat surface, they're building upwards. Makes sense. What other approaches are being explored?
Oh, there's a lot of excitement around new materials, ones that can potentially outperform silicon, things like graphene or carbon nanotubes. These materials have the potential to conduct electricity much more efficiently and handle higher temperatures, which could lead to some pretty significant performance improvements. And then, of course, there's the whole world of quantum computing, which that could completely revolutionize computing as we know it.
Quantum computing, that's definitely a topic for another deep dive, I think. But it sounds like even if Moore's law, as we've known it, is, maybe coming to an end, the future of computing, it's still incredibly exciting. It just, I don't know, it might look really different from what we're used to.
Exactly. The chip industry, it's constantly evolving, driven by this incredible interplay of scientific discovery, economic competition, and, well, let's be honest, geopolitical maneuvering. At the heart of all this, you have a tiny little component, the chip. This thing has become like the most strategic resource of the 21st century.
Speaking of strategic resources, I think we have to talk about EUV lithography. Miller, in the book, he calls it the holy grail of chip making, right? And it seems to be a major, major factor in this whole chip war. So what exactly is EUV lithography, and why is it so important?
EUV lithography, it's the technology that allows us to, create those most advanced chips, the ones with the smallest transistors. It's unbelievably complex and expensive, but it's essential if we want to keep pushing the boundaries of chip performance. Essentially, EUV lithography uses extreme ultraviolet light, which has a much, much shorter wavelength than the light sources that were used in those previous lithography techniques. This allows for much more precise patterning of the transistors on the silicon wafer, enables us to create chips with smaller and more densely packed features.
So it's like using a finer tipped pen to draw those super intricate circuits on the chip, allowing for more detail, more complexity. Who's leading the way with this technology?
There's this Dutch company, ASML. They're basically like the only game in town when it comes to these EUV lithography machines. And these machines, they're not cheap. We're talking upwards of like $150 million each. And even if you can afford one, there's a long waiting list. ASML, they've built like one of the most complex supply chains in the world to produce these machines, sourcing specialized components from companies all over the globe.
So it sounds like ASML is in a pretty powerful position.
They are. They hold basically a monopoly on the most advanced chip-making tools, which gives them, an enormous amount of influence in the entire industry. And this has made them a central player in the chip war.
How so?
The U.S., they've been putting a lot of pressure on the Dutch government to, restrict ASML from selling their most advanced EUV machines to China.
Yeah.
They see it as a way to, I guess you could say, slow down China's progress in, chip making. Access to this technology, it's become a major bargaining chip in this whole broader geopolitical struggle.
So in a way, these lithography machines, they're almost like the weapons manufacturers of the chip war. Whoever controls them, they have a significant advantage in this, race to create the most powerful and advanced chips. But even with EUV, there are still limitations, right? How much further can we actually push Moore's law? I mean, is there an end in sight?
Well, that's the big question, right? The one that, looms over this entire industry. As transistors get smaller and smaller, we're approaching those fundamental limits of physics. At some point, it just, I don't know, it might become impossible, or at least, insanely expensive to keep shrinking them.
So what happens then? Does innovation just grind to a halt?
Not necessarily. We may be reaching the limits of, Moore's law as we've traditionally understood it, but that doesn't mean progress stops. It just means we may need to, find new paths forward. Researchers are already exploring alternative approaches to computing, things like quantum computing and neuromorphic computing, which that takes inspiration from, the human brain.
That's mind-boggling to even think about, honestly. So we've gone from, moth-infested computers to chips that are pushing the very boundaries of physics. And this tiny little component, this chip, it's become, this focal point of global competition and technological innovation.
It's a remarkable story, and it's still unfolding. The chip war, it's far from over. It's going to continue to be this defining feature of the global landscape for, I don't know, for years to come, impacting, everything from the gadgets we use to the balance of power in the world. And that, I think, brings us to this crucial question, right? What does all of this mean for you, the listener?
It's easy to get, lost in the weeds a bit with all the technical details and the geopolitical maneuvering. But at the end of the day, like, why should we care about this chip war? How does it actually affect our, everyday lives?
Because, well, chips are everywhere. Think about it. They're in our phones, our cars, appliances, medical devices. I mean, even our kids' toys have chips in them now. They're the foundation. They underpin the entire digital infrastructure of, modern society. And as we've seen, control of this technology, it has huge implications. Global power, economic prosperity, national security, it's all tied up in these tiny little things.
So it's bigger than just, who's got the fastest smartphone or the latest gadget. We're talking about who controls, like, the future of technology and innovation, maybe even, the future of warfare.
That's right. And the fact that a handful of companies, mostly in Taiwan, they control the most advanced chip-making capabilities, that raises some serious questions about resilience, risk. What happens if something goes wrong?
It's like putting all your eggs in one basket, and that basket happens to be in a region with, well, let's be honest, some pretty serious geopolitical tensions. What are the potential consequences if this concentration of chip making power, if something happens to that?
Well, I think we got a taste of that during the recent chip shortage. Remember that? Led to delays in car production, prices for electronics went up. I mean, there were even like shortages of some gaming consoles.
Yeah, that was rough.
And that was just a glimpse, really, of what could happen if that chip supply chain gets disrupted in a major way. And the stakes, well, they get even higher when you start to think about the role of chips in things like critical infrastructure, healthcare, telecommunications, national defense.
It's definitely it's a wake-up call, for sure. These tiny chips that we never think about, they have this huge impact on our lives and, well, on the global balance of power. So what can we do about it? I mean, I'm not a chip designer or a government official or anything. Can the average person actually, like, influence the course of this chip war? Does it even matter what we do?
Well, you might not be, directly involved in the chip industry yourself. You can still make choices. As a consumer, as a citizen, as an advocate, every decision we make about the technology we use, the companies we support, it has an impact. It all adds up.
So what are some practical steps people can take?
As consumers, we can be more mindful about where the products we buy are manufactured, the companies we support. Do some research on the, supply chains of your favorite gadgets, the tech companies you invest in. Consider supporting companies that are, committed to ethical sourcing and sustainable practices. Those things matter.
That's a good starting point for sure. What about, like, as citizens, how can we engage with this issue more on a, like, political level?
Become more informed, about technology policy. Support initiatives to invest in domestic chip manufacturing and research. Advocate for policies that promote a more resilient and diversified chip supply chain. These issues, they might seem complex, but they have a real impact on our lives, our future.
And as, like, advocates, how can we raise more awareness about, like, the ethical implications of this whole chip war?
We need to start talking about these issues more. Things like intellectual property theft, forced technology transfer, the potential for this technology to be used for things like surveillance or even warfare. These concerns, they need to be part of the conversation when we talk about the future of this industry. We need to demand transparency, accountability from governments and corporations.
Yeah, it's a good reminder that technology, it's not, like, neutral, right? It's shaped by the choices we make, the values we prioritize, and we all have a role to play in shaping that future.
Exactly. This chip war, it's not just a battle between, governments or corporations. It's a battle that will ultimately affect all of us. And by understanding the issues at play, well, we can all contribute to a, more equitable and sustainable technological future.
Well, this deep dive has been, it's been a real eye-opener, honestly. We've gone from, those early days of vacuum tubes and moths in the circuitry to the, like, mind-boggling complexity of EUV lithography. We've uncovered this whole hidden world of innovation and competition, geopolitical intrigue, and it's all packed into these tiny little chips.
It is. It's a testament to, human ingenuity, but also a reminder of just how interconnected our world really is and the profound impact technology has on all of our lives.
Absolutely. So as we wrap up this deep dive, I'm left with, I don't know, a sense of awe, but also a sense of responsibility. It's up to all of us to be, informed, to be engaged, and to make those conscious choices about the role we want technology to play in our lives and in the world.
I couldn't have said it better myself.
Yeah.
And on that note, I want to thank you, the listener, for joining us on this deep dive into the chip war. We hope you've, gained a new appreciation for this hidden world of semiconductors and the impact they have on our lives.
And remember, the conversation doesn't end here. Keep asking those questions, keep digging deeper, keep challenging the status quo. Until next time, happy diving.